Good morning. I'm going to work through some of these maximum and minimum word problems that I assigned. I've selected 5 or 6 of them to give a try here too. Went from a kind of an easy one to start with to a little bit more complicated ones. So we'll see how many of these we can get done and how the video looks. So if you'll notice that the questions referenced at the top, so page 2 references the questions that I assigned. That was a PDF file that I sent through. And then this is question number 3. You can also find these solutions in many of the solutions already in the note that I sent as well. A lot of those questions are worked out. So here's a basic question right here where it gives you a rectangle with a fixed perimeter of 100 and it says what dimensions should it be to maximize the area. So I'm going to start by identifying the dimensions on the rectangle as x and y, and we know that the perimeter is going to be 2 of those x's plus 2 of those y's to add to give you 100. I call this the known relationship that's fixed at 100 for the perimeter. And then as far as area goes, we say area equals x times y, length times width. So we're going to take our known relationship and solve it for one of the variables. 2y equals 100 minus 2x. So y equals 100 minus 2x all over 2. Y equals 50 minus x. So we take that known relationship, solve for y, and we substitute it right in here. Just a quick point, you could solve this one for x the same way and substitute in for x here, but this is what I've done. So the formula for area now is x times y, and y is equal to 50 minus x. So this is the expression that we're going to take the derivative of and set it equal to 0, but you want to simplify it as much as possible. So a is going to be equal to x times negative x is negative x squared, 50 times x is 50x. So I wrote it in this order because it looks more like a traditional quadratic with the x squared term first. Put a box around that. That's a simplified version of the function that you want to take the derivative of. Your next step is to take the derivative of it, a prime minus 2x plus 50, and then set a prime equal to 0. So a prime equals 0 when minus 2x plus 50 equals 0. Transpose the 50, divide by negative 2, and you get x equals 25. To finish off this question, you want to substitute x equals 25 right back into here. So y equals 50 minus 25, y also equals 25. And as maybe you expected, in order to maximize the area of the rectangle, you make it into a square. So conclude by saying your dimensions should be 25 centimeters by 25 centimeters. The next question we're going to take a look at is number 5. And in question number 5, they give you a rectangular prism with an open top, and it has to have a volume of 4,000 centimeters cubed, and you want to minimize the surface area. So it's a square-based box with an open top, and you can see my dimensions are x times x for the length and the width since it's a square base, and then h for the height. So the volume, length times width times height equals 4,000, can be simplified in this question but to x times x, or x squared times h equals 4,000. And that's our known relationship. I'm going to take that known relationship and solve it for h. And say that h is equal to 4,000 divided by x squared. Now in terms of the surface area has only 5 sides. There's a square bottom, x times x, plus left, right, front, and back are all these same dimensions. They're all x times h. So there are 4 of those. There's the right side, the left side, the front, and the back. No top, so that's why it's only x squared. So here's our formula for surface area for this particular box. Now we're going to take this relationship, which I already solved for h. In this case, it was easier to solve for h than for x. So I chose h. That was a bit more obvious, and I'm going to substitute it right in there. So a equals x squared plus 4x times 4,000 over x squared. Simplifying that expression, I get this. X squared plus, cancel one of these x's off, and I've got 16,000 over x, which I will simplify down to this. Because it's easier to take the derivative of this expression than this one. So now I'm going to take the derivative of it. A prime equals 2x minus 16,000 x to the minus 2. A prime equals 2x minus 16,000 over x squared. I'm going to find a common denominator for this one so that I have a single fraction. I'm going to multiply this one by x squared over x squared. So a prime equals 2x cubed minus 16,000 all over x squared. Well, in maximum minimum word problems, you only need to find out where the derivative equals 0. So that's just where the numerator equals 0. We don't care about where asymptotes are. So we don't worry about the denominator equal to 0. A prime equals 0. I'll continue it on up here. That means when does 2x cubed minus 16,000 equals 0? So 2x cubed equals 16,000. X cubed equals 16,000 divided by 2. So x is equal to the cube root of 8,000. X is equal to 20. And then you want to substitute that back into the h formula to find out what h is. H equals 4,000 divided by 20 squared. That's 10, I think. So state the dimensions down here. The dimensions are going to be 20 centimeters by 20 centimeters by 10 centimeters tall. So the length and the width are 20 and the height is 10. The next question that we'll look at from page 2 still, it's a 3 meter by 3 meter piece of cardboard, and we're going to cut squares out of each corner. So we've done this type of question before where we take the piece of paper and rip the corners off, and I laugh at you when you make mistakes and rip the wrong corners off. This is what it looks like. We're going to make all of these x. So the dimensions of the squares torn out of the corner are all x, like that. And that leaves us with the base of the box to look like this. So the original piece was 3 meters wide. You took an x off the left side and an x off the right side. 3 minus 2x is the length of the base. And then this piece likewise is 3 minus 2x. So the whole thing was 3, take an x off of there and an x off of there. And so you have the volume of the box to be 3 minus 2x by 3 minus 2x, and these pieces get folded up to be x. So x times 3 minus 2x times 3 minus 2x, that's what you're going to try and maximize. So we're going to simplify that expression. Nine minus 12x plus 4x squared. So volume equals 4x cubed minus 12x squared plus 9x. So I took this expression, length times width times height, length times width times height. I simplified it down, and this is what I'm going to try and maximize here. What should x be in order to maximize the volume? So V prime rather, is equal to 12x squared minus 24x plus 9. So when does V prime equal 0? I see it can come and factor a 3 out of that. If I take a 3 out, I've got 4x squared minus 8x plus 3. That equals 0. I'm going to try to do this quickly here. So you can check my math on that, but I think if you factor this using our trinomial, you get this. So x either equals 3 over 2, x equals 1/2. So you get two possible solutions here. One of them works in this situation, one of them doesn't. X equals 3/2. If you put that into these dimensions right here, 1.5 into this dimension will make 3 minus 3 gives you 0. 3 minus 3 gives you 0. So we reject this one because it makes the volume a minimum where the length and the width dimensions are going to be 0. So x equals 1/2 is going to be the height of the box, and the dimensions of the box are going to be so the dimensions are going to be L equals 2 meters, W equals 2 meters, H equals 1/2 of a meter. So two more questions. Here's number 12. Number 12, they give you a cylinder. They want you to, they've given you a fixed volume of 1,000, and they want you to minimize the surface area of the cylinder. And surface area is equal to the area of the bottom, which is a circle, pi r squared, plus the top. So there's 2 pi r squared for area of top and bottom, plus the area of the side, 2 pi r h. So let's think about the dimensions on a box. We have R and H, and the formula for volume is pi r squared h equals volume. In this case, it's 1,000. So in order to simplify this or to solve for one of the variables, it's easier to solve for h. So that's what I'll solve for. You have to decide which is best in your situation. So we're going to take that known relationship right there, solve for h, and we're going to plug it into this expression for area right in here. So area equals 2 pi r squared plus 2 pi r times 1,000 over pi r squared. 2 pi r squared plus 2,000, 2 times 1,000, 2,000 pi. Nope, the pi's cancel out, excuse me. Over r. So I'm going to simplify that down to this, 2 pi r squared plus 2,000 r to the minus 1, and that's what I'm going to take my derivative of. This one's feeling a little fishy. We'll see what happens. A prime equals 4 pi r minus 2,000 r to the minus 2. 4 pi r minus 2,000 over r squared. And so I'll find a common denominator for this. I want to make a single fraction out of this, so I'll multiply it by r squared over r squared. So a prime equals 4 pi r cubed minus 2,000 all over r squared. So to set this fraction equal to 0, we're only interested in where the numerator is equal to 0. We're not concerned about where the denominator is 0. Those are asymptotes. So where does 4 pi r cubed minus 2000 equals 0? I'll have to continue that out up here. When 4 pi r cubed equals 2000, when r cubed equals 2000 over 4 pi, when r is equal to the cube root of 2000 over 4 pi, the 2000 divided by 4 gives you 500 over pi. I think this question only asks you for the radius. I'm not 100% sure. So I would say the radius is going to be that. That's the exact answer. And if you were forced to, you could find out height by plugging this into that expression, but it's messy. The last one I'm going to do from you is from page 3. That one was also from page 3. This one's from page 3 as well. And it gives you a half of a circle with a rectangle inscribed in it. And the one fact that they give you is that the radius of the circle is 2 centimeters. So given this shape, we want to maximize the area of this rectangle. How big of a rectangle can you put in there? Should it be a rectangle that's really short, like that one? Would this rectangle have a bigger area than this one? That's what we have to figure out. What should the dimensions be of that rectangle in order to maximize it? So the key to these questions is to draw the radius for the circle in, for the semicircle in, so that it stays within the rectangle. So there it is right there, and I'm going to draw it to one of these corners. And they tell us that this value is 2 centimeters. So I've created a right angle triangle where half of the width of the rectangle is x and y. So we've got 2 dimensions creating a Pythagorean theorem relationship. So the known relationship says x squared plus y squared equals 2 squared, or x squared plus y squared equals 4. So that's a known relationship. Now we're going to take a look at the rectangle, and we want to maximize the area of the rectangle. Well, the dimensions of the rectangle are going to be 2x times y. And we're going to take one of these variables and solve and plug it in there. So let's see what happens if we take and solve for y. We would say y squared equals 4 minus x squared. So y is equal to 4 minus x squared square rooted, or 1/2. I'll use the exponent 1/2 here. So squared on this side becomes square root on this side. Take this known relationship and plug it in right there for y. So a equals 2x times 4 minus x squared to the 1/2. You can't simplify that down any further. This is an exponent 1/2. You can't distribute the 2x in there because of that exponent. So my next job is going to be using the product rule to take the derivative of that. And I'll do it right down here. A prime equals first 2x times the derivative of the second 1/2. 4 minus x squared to the minus 1/2 times negative 2x, plus second 4 minus x squared to the 1/2 times the derivative of the first 2. So this is what I'm getting for this expression as I simplify it. A prime equals negative 2x squared. If I multiply all of these together, I get negative 2x squared times 4 minus x squared to the minus 1/2 plus 2 onto 4 minus x squared to the 1/2. So between these two, I'm going to common factor. I can common factor out a negative 2 and a 4 minus x squared to the minus 1/2. And that leaves me, if I take this out of this expression, I'm left with x squared, I think. And if I take this out of this expression, I'm left with minus 1 onto 4 minus x squared to the 1. So when I simplify that down, a prime equals negative 2 still in the numerator. This square bracket becomes x squared minus a negative x squared, or 2x squared, subtract 4. So that comes from this right here, all over 4 minus x squared to the positive 1/2 in the denominator. So I want to take the derivative and set it equal to 0. That means I'm just looking at the numerator. When does a prime equal 0? When negative 2 onto 2x squared minus 4 equals 0. So when does that numerator equal 0? When 2x squared minus 4 equals 0. When 2x squared equals 4. When x squared equals 2. When x equals plus or minus the square root of 2. So x equals root 2 centimeters is this distance right here. So the dimensions are going to be, the length is 2x, which is going to be 2 times root 2, because we just decided x was root 2, and the width, which was y, and y was equal to, I don't know where I put that, oh yeah, y was equal to 4 minus x squared to the 1/2, 4 minus root 2 squared to the 1/2, 4 minus 2 to the 1/2, 4 minus 2, 2 to the 1/2. So y, which is equal to the width, is equal to square root 2 centimeters. So there's some questions for you to look at. I hope that helps.